Hello, this is Mrs. Spellman. Welcome to GCSE Computer Science. Let's get started. So today, looking at the big picture, we're working on memory and storage, in particular, how sound is stored on a computer. So what I would like you to do is pause the video and take stock of where you are right now. Once you're happy you've done that, if you fill in the slip in your green book. And now we're ready to learn. So analog, what does that mean to you? Have you heard of an analog watch versus a digital watch? With the analog, the hand keeps moving around, whereas with a digital watch, every second a new display comes on the screen. So one of them is moving constantly, and the other is discretely every second. So it's like continuously with the analog watch, that second hand is continuously moving around. So it's a continuous wave. We're looking at an analog signal now being a continuous wave, and here we're now talking about sound. So this would be an example of how sound is recorded. How do we store that digitally? How do we show that on a computer? How can we actually store this wave and then reproduce it again or reconstruct it again? So let's think about that. So we're going to take samples. We're going to take so many samples per second, but just to illustrate this to you, I have got a sound wave here, and it is shown over 30 seconds. So this is 30 seconds long. And anywhere along here, we can work out the height of the wave. So what I'm showing here with these pink dots is that every 5 seconds, I have taken a sample. I have worked out the height of the wave at that particular point. I would need to store that, and I would give it a value, a denary value, which I can then convert to binary, and that's how it would get stored. Now, the thing is, the more bits I have available to me to store that, the better the quality of the sound, just like color depth. Also, I could store more samples, so I could double the number of samples I'm going to take, and that also is going to increase quality, but it's going to increase the amount of storage that we need too. So you're seeing here a trade-off between quality and the amount of storage. The other thing that will affect the amount of storage or the size of the file is the number of seconds, the duration of the sound. Okay, now in reality there are more samples taken per second than this. However, this is fine for our purposes. And no matter how many samples you're taking, it's never going to be the same as the original analog wave. However, the more you take, the closer it's getting to the real thing. And of course, the human ear won't notice if it's a good quality sound file. These samples that are taken per second are measured in Hertz. That should be no surprise to you because the beat of the internal clock is also measured in Hertz per second. So let's look at some terminology. So bit depth is the amount of bits available to store each sample. And now we're back to something that you might recognize from before. In the units video, we looked at how we could work out the size of a sound file. And we do that by timesing the sample rate, the duration, and the bit depth. So the sample rate, how many samples are we taking per second, for example? Duration, how long is the piece of sound? 30 seconds maybe. Bit depth, for each sample, how many bits are available for us to store that value? All those times together gives us a sound file, and we don't worry at GCSE about the metadata. So we've done this before, so I'm just going to go through all these calculations here. We're just timesing them all together, changing the units so that our answer is finally in megabytes. So 2.4 megabytes is our answer for that particular sound file. So what have we learned? We've learned that sound waves are analog and they need to be stored as a binary file. They need to be digitized. A sample is taken at set intervals. A numeric value represents the sound wave the height of wave, for example. The more samples taken in a set amount of time, the better the quality of the sound. The more bits available to store each sample, the better the quality of the sound too. Samples taken, bit depth, and duration can affect the size of the file, and the better the quality, the larger the file. And that's it for sound. So do pause the video and now take stock of where you feel you are now in your knowledge of how sound is stored on a computer. And once you've done that, if you fill in the slip in your green book, and I hope you have made progress in learning about sound.